Hi, my name is Brandon Burke. I'm a composites design and manufacturing engineer for Applied CAX. Today I will be going over the process of converting NX composites designs to Fibersim definition. The scenario we are simulating in this video is where a client, company A, has defined a composite part using NX composites because they did not have access to Fibersim. But now an end user, company B, the manufacturer, needs to utilize some of the more powerful features contained in Fibersim to follow their established standard processes. Company A is an engineering firm that designs composite parts using NX composites. After the design is complete, the producibility needs to be ran for all plies before we can export the HDF5 file. From the Composites tab, we can select Export HDF5 after validating all the producibilities are up to date. We're going to rename the file and then select all 10 plies. Note there are two different fiber orientations you can choose from, rosette mapping or producibility. In this case, we'll just leave it at rosette mapping. And now we can export the step file. In the step file, we need to have all of the necessary data to recreate the laminate and rosette in Fibersim, such as the laminate surface, the net and extended boundaries, the rosette origin, and the 0-degree direction. We're going to grab the origin and the direction of the 0-degree there. Company B will start by importing the step file into NX. We'll grab that file and click OK, and it's going to process that. And now we can open that part. Note that it just has the non-timestamp geometry and the body because it was just a step file that we imported. Now we can open Fibersim and create the laminate definition. So we'll right click, create new. We'll select the layup surface and the net and extended boundaries. In this case, we'll make them the same. And the yellow arrow is indicating the normal direction. So now we'll create the rosette, right click, create new. We'll select the origin and the direction of the 0-degree curve. And click OK. You'll note that there is no ply definition, so that's because it's an empty model. Now we can do File, Import, Analysis, Ply, and it's CAE Import to Overlay Zones. So we'll right-click, Create New, and select the HDF5 file that we had delivered to us. Here we have all 10 plies. Note the mesh area on the right. 8 of them have the same mesh area, and those are all our full body plies, so we'll grab all 8 of those at this time. And then right click, create zone. And then we're going to change the creation method to automatic and click preview overlay zones. Click OK. And then we'll right click on that and select as full body, and then right click again and create ozone. That's creating the overlay zone and all the definition in Fibersim. And we'll repeat that again for ply 9 and ply 10 individually because they have different boundaries. So if we click on that, you'll be able to see it in the window on the left. You can see the the ply boundary for ply 9. And click OK. And then we're going to refine the curves here. Sometimes with the HDF5 files, you have a bunch of points and it's creating curves directly over the net and extended boundaries, and sometimes it'll result in an invalid boundary. And so we're just going to remove those points. And then we'll refine that curve and click OK. And then we'll right click on that and create the ozone, which is creating the ozone definition, the overlay zone definition for us. We'll click OK and do the same thing for ply 10. So right click, create zone, preview overlay zones. You can click it and see it in the window and click OK. We'll right click, and refine the curves again, and we'll remove the excess points that are basically on the boundary. There is a button for that. In this case, we're doing it the longer route. Then we'll select remove and refine curve and then click OK. And now we can right click on that and create that. That's our final ozone, and that was another positive message. There were no errors in that. So we can click OK and close out this window. And now down under the advanced, you have the overlay zones. Here's the 3 that we just created. You have the full body ones and then our 2 ply step overlay zones. We're going to select all 3 of the overlay zones and click this icon here. It's the zone to layer analysis. The resulting objects, note that you've got layer or layer and ply. In this case, we'll just do layer and generate all the layers. However, you can take a shortcut and generate both layers and plies at the same time. So we'll click OK, and then note that you've got all these new zone transitions created, these TAVs, and all 10 layers for all 10 plies. Now we'll select all the layers and click Generate Plies. And now it's created all of that ply definition for us up here. And now you are free to modify it however you wish. In this case, we're just going to right click, modify, and change the name to match our naming convention of P001 for ply 1, comma space 1, and that'll name them all 1 through 10. Another cool feature in overlay zones is you can create a zone-based solid. So we're going to do that now. We'll right click, create new, and we're going to generate a solid body based on these overlay zones that we imported. And that is pretty much it. Now all of the Fibersim definition has been established and is ready for further processing to support the manufacturing process. I want to thank you for your time today, and I hope that you found this content beneficial in learning how to convert NX Composites designs into Fibersim definition.